Well, let's talk about the course introduction. Yeah, basically, what have you gotten yourself into? So, welcome to CS475, 575, parallel programming. This course is pretty much about desktop parallel computing. We will talk about multi-core, we'll talk about SIMD, we'll talk about GPU. However, we will also talk about message passing interface, which is cluster type parallelism. So this will give you an immensely broad background in lots of things to do with parallel computing. And here are subtopics within that list. The class resources page is here. Memorize this. If you've had me in class before, you already know it. It's cs.oregonstate.edu, squiggle, the tilde character, MJB slash, and the 500 level name of the course. So 575. Memorize it, bookmark it, check it often, because a lot of times I will put interesting things up in the announcements section and won't necessarily spam you all with email to let you know it's there. If it's something super important, like I've changed a project due date, I will certainly let you all know by email. But yeah, get used to looking at this. Also, everything. That's why it says it here that you need for this class is out there. That is, yes, it's a long page, but it's a superset of everything you need to know. I will still populate Canvas with week 1, week 2, week 3, and so on. But basically, those are all subsets of this class resources page. Okay, eCampusers. Yes, we have an eCampus section, both the undergrad and the grad parts of this course. And I'm really glad you're here. It's just great that you're willing to take an online course. And I know that presents difficulties all of its own, and I'll try and help you work through those. But this is exactly the same course, whether you're on campus or online. Same course, same material, same notes, same projects, same quizzes, same tests, same online office hours. The TAs and I will be setting Zoom office hours, and anybody can go to anybody else's office hours. And you don't have to be in certain sections to go. There will be recorded videos that go along with the notes. Those are especially for the online students, but of course, the on-campus students can look at them as well. In our table of notes, they're called LV. There's a link that says LV. That stands for lecture video. Okay. Also, and this is especially for eCampus students, but on-campus students are welcome to come too. I set up a time every week to do a live lecture. Now we'll just in live go over the material for that week. I do that so you have a chance to ask live questions. Now I record these, so if you miss them, you can listen later. And I take the chat window contents and answer questions and then post that as a PDF. So this is just one more way that people can succeed in the course. Everybody learns differently. And so the goal is to present the course in multiple ways, and then you pick which ones help you the most. My Zoom room is this. This will be for my office hours and for the live lectures. Okay, yep, there I am. I'm at the Kelly Engineering Center. I've been at this for a while, and I've been at this with a bunch of you. And yeah, I'd also dabble in K-12, especially where it involves computer graphics. Okay, office hours. Again, the TAs and I will set office hours, but just kind of know that I will answer emails. Now, I'm a compulsive email checker. That doesn't mean I can always return the emails. Sometimes I'm checking them surreptitiously during a meeting or something, but I will get back to you. I do prioritize the emails. There's, super duper important questions on emails go first. Things that you could have found out by looking it up on the resources page go last, and so on. Um, yeah, and again, office hours and live lecture will be on this Zoom room. And of course, like a real room, it's only available when I open it up. I know sometimes students just connect to it hoping I'm there to answer questions, but unless it's office hours, I'm probably not. So yeah, don't come to expect that. Okay, I have a couple of dogs, and sometimes I do office hours from home, and sometimes I do these recordings from home. And so you may get to know them. You probably won't see them. Um, Neither of them likes to be picked up to hold in front of the Zoom camera, but you're likely to hear them because they both love to bark at vehicles coming down the street. I don't know what there is in that, but they do it. So yes, you will likely hear them. Class textbook, there is none. Okay, the class material will consist of handouts and notes taken while watching the videos. Okay, there's nothing you need to pay money for. As we like to say at Oregon State, affordability matters. And course incoming expectations. This is a programming course. I hope that you all know some programming in something. If it's Python, that's fine. We're going to use C and C++. But if you know Python, then nobody has to explain to you what a for loop is. So you should be familiar with programming concepts. And if your programming experience is not C or C++, that's fine. There will be gobs of help, gobs of sample code. Basically, it's relearning a different syntax, but the concepts will be the same. Math side, be comfortable with algebra. There's going to be some times we have an equation where y is a function of x, and I'm going to say, now let's make it x is a function of y. Yeah, you should kind of understand what went on to do that. There is a time in this class I will mention calculus, but you don't have to do anything with it. We're just sort of setting up a certain kind of problem using its calculus equations, but then we will quick drop down to the algebra. Um, Most of these assignments can be done on the Linux systems, which maybe you've had access to for other classes. On our Oregon State system, they're called the flip machines, and there's actually a whole bunch of flips, flip 1, flip 2, flip 3. We also have a machine that's very much like flip, but it's only for this class called Rabbit, and we'll talk about those later. This is far and away the easiest way to do most of the projects is on Linux, but that means you should know some of the Linux commands. You can do, I think, most of the projects, not all of them, but most of the projects you can do on your own machine, especially if your own machine has a GPU on it. This last one is really important. A lot of what we're going to do is take performance data. One of the things you'll come to understand about parallel programming is doing parallel programming at all is not hard, not hard at all. What's hard is doing it well. And so we're going to change some parameters and things and see how that affects the performance. What does it take to do parallel programming well? Well, because of that, we're going to change parameters. It would be, required, it is required that you have some way of taking that data and putting it in a spreadsheet. Okay, put it in a box of numbers, and then a way of making graphs from that. And then pasting those graphs into a word processor document, and then turning that word processor document into PDF. Okay, so you need software tools to do that. Something to make a table of your values as they come out of your program into a graphing package, into a word processor where you write your report and include your graphs, into generate a PDF. And it's the PDF that you will be turning in. So if you don't have any tools in some part of that tool set chain, make sure you go get them because you will need them and you will need them right away. So this is just kind of a quick warning. So welcome to CS475, 575. I think we're going to have a lot of fun together this quarter. It's a cool topic, and I think you'll figure out a lot of things you can do with it.